So good morning, everyone. I'm Anup Dubey, Senior Analytics Practice Lead at Aditya Birla Group. So first of all, thank you, everyone, for coming to this session. What I will talk about here is how do we bring AI from the perspective of having circular economy principles embedded into our business decision makings. While I will focus specifically on logistics and procurement because that's the area I manage at Aditya Birla Group. But we will start with some generic principles around what is circular thinking and how AI can be embedded with the principles of circular thinking, and then move on to a very specific use case. Bear with me for next 3 or 4 slides. I'll probably give some general gyan with the next 3 or 4 slides here. So you see a happy gentleman here, celebrating his business in 2011 when the world was about 7 billion in population. The World Bank says that by 2050, the world population would be around roughly 10 billion, which means each company will be scoring for resources. Now, so how do businesses foolproof their supply and demand in this resource-constrained times? And mind it, by 2030, there's a projection that 2.5 billion new customers will be added to the middle class group, which means they will be consuming more and more resources to improve their lifestyles. Now, circular economy principles, if applied to or embedded to our business processes, can help us decouple our economic profits, our bottom line, from resource consumption. Not completely decouple, but what I would say is loosely couple our business growth with the resource consumption and depletion. What it basically does, the first 2 tenets that you see over here is rethinking resource management, which basically means how do we keep our resources, how do we keep our products in circulation as long as possible, which basically is a challenge to our traditional way of doing business, which is take, make, and dispose model. Again, this will eventually lead to a part of sustainability, but what it will do is it will, decouple our business or bottom line with the resource consumption. Now, to enable the 1 and 2, what we basically need is a strategic thinking process that will allow, or a change management process, right? That will allow us to, enable rethinking resource management and a part to sustainability into our business decision making, into our daily operating principles. So that's where the 3rd point comes into picture: the innovative strategies for change. It's not just to enable rethinking; it is also about new business opportunities, new areas where we can, contribute both the top line and the bottom line of our businesses. So what are these 7 R's of circularity thinking? It's basically redesign, reduce, reuse, repair, renovate, recycle, recover. If you focus on 2 to 7, the points number 2 to 7, these are basically the first and 2. They're enabling the first and 2 tenets of circular thinking. And the first point, which is redesigning the business model or the industrial process, is basically the 3rd part, the innovative strategies to enable these changes. Now, before we go as to how these 7 R's gets applied to our logistics and procurement functions, let's focus on the framework for fostering circular thinking into our business process. Basically, 4 points over here. We need to start thinking of the product design at a very early stage, and I will give some anecdotal examples over here, related with more of what we do at ABG. So the first one, the product, influencing the product design very early, in the very early stage. You're all aware about Ultratech. It manufactures cement. Now, the highest grade of cement comprises mostly of limestone, along with some gypsum. Now, a similar grade of cement can be made using, by mixing the limestone with certain percentage of fly ash. without compromising on the performance of the cement. Now, this fly ash is basically an industrial waste. And one of our businesses, Hindalco, generates tons of it, basically. So by reusing and by thinking of product design at a very early stage and really going through that design thinking process, we can reuse our waste. And this, it's not just about reusing waste. Definitely it is helping us, be more sustainable, but it's also reducing our cost. It is also reducing our energy consumption. If you understand, it has a two-step process. The cement making process, you have a clinker and you have a grinding unit. And fly ash comes in the picture in the second stage in the grinding unit. So clinker is more energy-intensive process, right? So if we use less of clinker in this whole process, where the limestone is typically used, we are basically saving on the energy. The second principle, which is think as a service model, is again very critical. It challenges our traditional take, make, sell model. But what it tells us is we have to start thinking of the end product or the end consumer experience end to end. Let's take an example, a very common example of car rental services for driving. We are all aware of that. But what it is basically doing, all the cars that are owned stay idle 90% of the time, right? Now, by having these services being provided to the end customers, customers now have the option of not buying a car, but going through the services, getting the same benefit as against owning the car. And I'm discounting the prestige that comes with owning the car and just the functional part of it, right? That customer can have the same benefit as against owning the car. The businesses have all the incentives to keep that car in the, in the circulation or increase the life cycle of that car as long as possible, which actually is, also helps in reducing the, basically the resource consumption here. But this model is not applicable to all products or businesses, right? Let's take an example of apparel industry. I believe no one in this room would really like to wear jeans worn by someone else or socks worn by someone else, right? So what did H&M did back in 2013 or 14 was they asked their customers, the consumers, to start giving back their old clothes, right? In exchange for some future vouchers, that they can use it 1 year down the line. And a year down the line, they launched recycled denim jeans. And thereby, basically, they helped improve the customer loyalty over there. But that was not the real reason why they did this. The real reason why they did this was they wanted to hedge against the cotton prices. So by getting the cotton from the used clothes back into their supply channel, they basically were hedging against the cotton prices. And we did a very similar thing at ABG with wool prices. I'll briefly touch upon it later on. Now, a similar situation can arise in B2B space as well, where we are making our suppliers, our customers our suppliers, right? They are now providing us back the raw materials that we need in our manufacturing process. Hindalco recycles a lot of aluminum cans, right? So we take back the aluminum cans from our customers and basically converting them into suppliers. Which brings me to the third point of supply chain agility. We need to have a multi-directional logistics flow. We need to have reverse logistics embedded into our supply chain to enable the agility. And the key here to do that is not just the infrastructure, it is basically also the seamless sharing of the data. There are so many parties getting involved in this process that data sharing is becoming very critical, and the need for centralization of this data is also coming up, and that's why this whole new platform, the governments are coming up with initiatives. Like in India, we have ULIP now, where you can get a lot of data around your transporters, around your truck drivers. So that data is becoming very, very useful to enable the supply chain agility. The fourth point is pretty much clear. We need to, we cannot achieve, we cannot do all of these things within our business by ourselves. We have constraints on resources, manpower, thinking power. So we need to bring the wider ecosystem, into our ways of working. And so that basically, as we engage with more and more startups, we build our capability faster. So that's basically the 4-point. Now, so what does this circularity principles that we talked about mean for logistics and procurement? And this is a factor map that highlights the entire cycle of manufacturing process, but with some integration, but I'll focus largely on the distribution, which is the logistics part, and the procurement piece of it. The distribution, let's focus on the distribution first. We can do multiple things over there, just from the perspective of applying the circularity principles, but focusing primarily on deriving benefits for our organizations, for our functions. The first one, let's look at this bottom one. I don't know this one. Reduce lead distance and emission. We have come up with AI or analytics-based solutions for route optimization. Companies like Hindalco, the trucks travel about 1,000 kilometers. Pulp and fiber trucks travel again more than 1,000 kilometers. So how do we optimize route which can reduce the total distance, reduce emissions? How do we optimize our network? If you think of UltraTech, it is not a cement manufacturing company, it's a distribution company. 30% of the cost is basically goes into, we charge customers for it. So if we help optimize our network distribution, how do we reduce the cost to a customer? And again, in the process, we'll reduce emissions because, as we optimize our network, we are reducing the lead distance. How do we use our assets better? So think of the truck coming in the plant and getting loaded with the materials. The same assets can be optimized under different operational constraints and can do a lot more dispatches. So, how can we use rakes that are used to transport a lot of semi-finished goods, raw materials from one plant to another for processing? How can we use the fleets that we have contracted to do our deliveries, right? So for example, if we have a plant, and I talked about two of the businesses here, Hindalco and Pulp and Fiber, two long distances, two businesses where the trucks travel very long distance. Now in the onward journey, it's definitely carrying the product that we want to deliver to our customers, but on the return journey, it is basically coming empty. So how can we use that fleet for some other purpose, and in turn, basically improve our asset utilization of the fleet? So reuse of fleet in the return journey is a very critical aspect here. And again, it has multiple levers to it. We work on something called a backhaul, where we identify opportunities using data science on what opportunity exists in the return logistics. How can we cross-utilize different types of trucks for different use cases, for carrying different materials? And how do we bring all of this together from multimodal perspective as well? Now, there is a big shift in going away from road to rail, right? And government is also investing a lot. Hindalco is supplying its aluminum to make rakes now. But when we think from the logistics perspective, now you have to integrate your road with rail. And you have to really bring all your data together. You have to really drive synergies in the data and the analytics across your value chain. So that's on the logistics front. On the procurement front, again, these are very common examples. But bringing all of these together to enable value for our businesses from the lens of circular thinking is very, very critical. One of the key projects that we worked upon at UltraTech was a fuel mix optimization project, and I will explain that. But we brought 3 different levers to it. We brought demand forecasting, we brought price forecasting, and we brought what is the optimum mix of, what should be the optimum mix of fuel to achieve our energy requirements at plants. And all with the objective of reducing our inventory, reducing our fuel consumptions, and this is the use case that I'll touch upon a little bit later in the slide. And again, I talked about the case where Hindalco is supplying fly ash to Ultratech, right? Now, each businesses generate many different kind of waste. So how do we map this? This is not really an analytics problem, but it is a precursor to analytics, how we create a data lake system where we are able to get this data, right, into this data lake platform, on top of which we can create a marketplace for mapping the supply and demand of raw materials, and then drive analytics out of it as well. And one of my colleagues is here, Soumya, who works extensively in that area. So these are the various possibilities, and this is not extensive. We can, as a thought process evolve, we will keep on expanding this. But I just want to highlight some of the key areas that we have been working upon. Now, we know what to work upon, but how to work upon, right? How do we identify what is the framework to operate, So basically 6 steps process over here. You identify the right matrix, that's the start. What is the business objective you are trying to drive? Recycling rate, reducing your energy consumption, reducing your fuel mix consumption. Then you start with the process simulation. The process simulation here could be, just the process mapping or creating a digital twin of a process. Basically, you identify where are the, you want to lay out the performance, variability, what are the bottlenecks in your processes. And the key here is, don't think in silos, think about your process end to end, lay out the entire value chain of your business process. And then you challenge the status quo. Challenging the status quo means basically, what problems you are trying to solve. Are you challenging the, your current process designs or parameters? And you can use various upcoming technologies like Gen AI to do that, or you can rely on some of the very old concepts like design of experiments to do that. And then once you have your problem statements, you basically optimize those problem statements, right? And how do you optimize your channel? How do you optimize your reverse logistics? You have very good optimization platforms now, open source or paid platforms like Gurobi and all those things, which can, you can use those to optimize the problem statement definitions that you have in the step 3. Now, once you have optimized it and you have handed over to the end users, how do you decentralize? I mean, you cannot be as analytics team, you will not be there when it becomes business as usual, right? You want the end users to adopt it, you want the end users to start using it, the platform, and then as you start using it, not just the insight, but interact with that platform as well. So, there are, again, Gen AI is an upcoming, a current fad, I would say, but, it can be used to empower your agents to do some sort of a predictive maintenance on your machines. That's just one example, but there are a lot many others that one can do. And then again, once you have done all of this, keep planning in advance. Do your forecasting, and I talked about how H&M did back in 2013-14. We did something on wool prices forecasting, where we helped businesses forecast, some, 1 month, 2 months, 3 months, 6 months down the line, what the wool prices would be, and the business can take, the actual business decision lies in the hands of businesses. We need to empower them. So the choices could be they could go for financial instrument for hedging, or they could go for solutions like what H&M did. Again, that's an hedging only. So just a 6-step process. It's a very useful thing to think holistically about how do you go about deploying your AI from the perspective of circular thinking again. Now, this is the one use case that I wanted to touch upon. I talked about it. A very important project which has got a lot of traction within our business. How do we optimize our fuel mix? And I'll use this framework here to relate a little bit on this use case. So what we got from the business was this particular, what this particular KPI, matrix, reduce raw material inventory cost by up to 4%. So that's the step 1. But what do you do after that? Is the step 2, right? You lay down your process. So you lay down who are the suppliers, what are the different raw materials. Are you using coke? You're using pet coke. You're using coal. You're using other types of, fuel raw materials. and you source these through various, extensive distribution of your supplier network, not just one. Then you blend them, right? And there are various operational constraints at the plants in terms of using this. And then and you produce your final product. Now you map this. So that is basically what the step 2 is, process simulation. Then you come to the step 3, which is applying your basically, establish your problem discovery framework, and it could be, you can define your own framework as to how do you want to arrive at your problem statements. But it's very critical to do that, because when we did that, we got this 4 statements. Basically, this was the exact 4 problems we are trying to solve to achieve this metric. What and when to purchase, at what price, from where to purchase and where to distribute. And if you see, these 4 questions has brought multiple elements of AI together. It has brought demand forecasting, it has brought price forecasting into the picture. So, and then what it does, it uses that as inputs and the operational constraints to do a optimization problem. Again, so basically, once you have your inputs in terms of the different, your price forecasting, your demand forecasting, and you have your operational constraints defined at your plant, you run a global optimization algorithm to help solve for these 4 problems. So that's basically your step 4 and step 6 covered. The centralized decision making, how do we do that over here is, we create algorithms, we create platforms. Once you have done this, right, the businesses or the plant users or the central procurement cell has to use this platform maybe on a monthly basis, maybe on a quarterly basis, whatever their planning cycle is. So we need to provide them a data platform sitting at the back of this product where they can do various simulations. Keep doing those simulations by redefining your operational constraints. These are not static operational constraints. They will keep on changing with time. So you have to keep on simulating, but we cannot keep on developing the product all the time. We have to enable the product so that, at the front end, they can keep experimenting, they can keep simulating. So that's where having a nice, or a well-architected data architecture or a platform comes into picture. So just wanted to illustrate how this the 6-step process was used in, in one of our use case. And this is pretty much now we have done for one particular, fuel mix optimization. We are now doing this for other raw materials where we have huge spend. For example, pulp is another raw materials where we are extending this. A lot of businesses are showing interest in this. So now we have, what we can do, the principles and what framework we can follow to operate. But how do we get there quicker is very, very important. I think the first 2 points are pretty much, it's very standard. Use that in all our digital and all our, digital transformation slides. But what I really want to highlight here is this. Sustainability or its concepts are basically standalone function. Aditya Birla has a sustainability group as well. They try a lot of such initiatives. But how do we embed those principles, not just in our analytics functions thinking, but also in other business process? Make just like Six Sigma was few years down the line, right? Everyone was thinking from that perspective to keep on improving the process. So if we have to achieve a future where the industry is run on a very resource-efficient manner, we'll have to start embedding these principles more and more into our ways of thinking and working. The third point basically here is basically, any solution, you will do it for a plant, you will do it for, replicate for a few plants. But now if you have a global supply chain, where your distributors are scattered around, your plants are across various geographies, how do you execute and scale? So thinking about moving away from a project mindset to a platform mindset is very important. And there's a lot of technical components to it. How do you improve your code quality? How do you reuse your codes? And there are multiple layers to it. I don't want to go over there. It will become another session in itself. But both A and B, having a right data strategy. How do you create your data lake architectures, which can enable sharing of data? How do you catalog those data? Those are very, very critical, because one of the key things to enable circularity is sharing of data. And if you don't have a platform to share your data, it is going to be it is just going to take a lot more time than usual. And the third point is basically around, have a center of excellence around core analytics capabilities. I talked about optimization. Now that optimization can be used in procurement, that optimization could be used in logistics, that optimization can be used in, sales planning maybe. So having a framework around the core optimization capability, or it could be around pricing or forecasting, really allows you to scale faster. You can have, let's say, an Aditya Birla group, we are a central team. But let's say I want to use, let's say tomorrow Hindalco builds their own analytics team, and I want them to use this optimization capability. They don't have to start from scratch. They can use a framework that we have developed and quickly replicate that. So it's very critical that we have this center of excellence built around these core analytical capabilities. I think the third one, we briefly touched upon it. We need to widen our startup ecosystem. The startup ecosystem have the tech ability, and what I've seen from my experience, I engage with startups almost on a daily basis now. I think that has become my core job. They have the technical capability and agility. What they don't have, the business acumen. And that's where we come into picture, and that's where the concept of co-build comes into picture. We have to really co-build with our partners to make them successful for us to be successful. So that's it. Thank you, guys. I think I've taken my 20-minute slot. Sorry? No, there's nothing more. It's just, thank you. It's just, hopefully it was useful.